Alright, so welcome back to the video. So in this case, it's going to be section 42122, kind of some inequalities. So we talked about this when before break, Friday, obviously, that we kind of left. As you can probably tell, in this case, again, I'm not back yet. I'll be back on the following day, January 7th. So please make sure that you're watching this video entirely. Again, it's going to help you kind of put the pieces back together, obviously, since we've been almost off 2 weeks. Kind of give you that refresher. That'll be for the final part of chapter 4, and then kind of we go into the chapter 4 test next week. So in this case, again, this video will kind of cover the inequalities, and then it'll also kind of cover how to solve them as well, speaking on the graphs, and then different number lines as well. So the first one, kind of a question here. It says for 460 Bert and Ernie were solving the inequality 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. We were looking to the graph in the problem of 458. That was the problem that we did previously in day 1. Can't we change this into one parabola and solve our inequality that way, he said? Can't we find the solutions by looking at the graph f of x squared plus x minus 6? So in this case, where did Bert get the equation x squared plus x minus 6? So using your skills, probably guessed right away that in this case, when we had this, we ended up using it with 2x squared plus 5x minus 3. And then in this case, we end up switching this to equal sign and then just solve it from the idea of x squared plus 4x plus 3. So what you're going to end up noticing here is, again, Bert was looking at this problem and said, and you probably noticed right away that, hey, we have two things that we have four terms that are being squared. So therefore, what we need to do, we need to simplify both sides by setting it equal to a term. So in this case, as you can probably guess, x squared minus 4x minus 3. And I do it on the other side as well. So in this case, again, I get the value of negative x squared minus 4x and minus 3. All this simplified. So in this case, all those cancel out. And what's left then is just the value within the left side. So therefore, 2x squared minus a single x squared gives you x squared. The next one, 5x minus 4x, gives you the value plus x. And then, in this case, and the value negative 3 minus 2 gives you negative 6. And that's all equal to the value 0. And as you can see, that's probably what Bert got it. So in this case, when we solve for it, we're able to then this solution based by factoring out and then being able to solve from there. So when we do so, what we're going to do, we're going to go ahead and factor this out. If you haven't done this already. So 2 minus 6 and 1, those are going to be x minus, or x plus 3, and x minus 2 is equal to 0. And therefore, again, we end up doing this, we end up setting them equal, so therefore we should get x is equal to negative 3, and then x is equal to positive 2. So in this case, what we have here is we x values, again, for our x-intercept. So in this case, instead of just a regular problem, what we're actually going to do is we're actually going to go ahead and solve these inequalities again by looking at their solution basis. So in this case, where did you get the solution? With that, what we're going to do is we're going to go ahead and graph this solution. So one of them is at the value of negative 3, 0, and then the other one is at the value of 2. All right, so in this case, what we're looking at is we're looking at the solution for this inequality here. So what we want to do is we obviously want to go ahead and make this parabola and see what it looks like. And then from there, what we can do is we can kind of use our simplified form and be able to then find those specific values where to actually shade on the graph. So in this case, what I need to do is I need to go ahead and figure out what is my vertex point. So I have two x-intercepts here. If you recall, back in chapter 2, we actually figured out how we can actually solve by having intercepts. So in other words, what we're going to do is we're going to take the values of our x-intercepts, negative 3 plus 2. We're going to divide by 2 to find that specific value for x, where our vertex is. So in this case, if I do negative 3 plus the value 2, and in this case, when I do that, I end up getting the value of negative 1 equal to, or over the value 2. So in this case, that value is going to be 1/2. Now, when we do that, we end up getting the value of 1/2. So therefore, what we're going to do is we're going to go ahead and take that and plug it in for the other value. So in this case, we have the value of x, so we can self-integrate y. So therefore, y is equal to, and then negative 1/2 quantity squared, and then minus 1/2, and minus 6. So in this case, if I do a negative 1/2 squared, in this case it's going to be 1/2 times 1/2, so therefore it's going to be positive 0.25, or 1/4, minus 0.5, and then minus 6. So again, I just changed the decimal point just to be able to calculate them a little bit easier. Again, if you're comfortable with fractions, please do so. So in this case, I do that value. I do 0.5 minus, or excuse me, 0.25 minus 0.5, which gives me, in this case, negative 0.25. And then on minus 6, so I'm going to get about negative 6.25. That's going to equal the value of 1. Okay, so therefore, point, in this case, we're going to go negative 1/2, so about right here, and then go down to about negative 6.25, which is about right here. So in this case, again, it really doesn't matter what the vertex is per se, because in this case, again, all we need is those 3 points to have our parabola. So now what we have here is we have a parabola, again, with that solution for the problem. Now, in this case, with an inequality like this, when we're drawing this, obviously, if we have an equal sign, obviously it's going to be whole numbers, or excuse me, a solid line. But now, since we're talking about an inequality, what we're actually doing here is we're actually trying to find the solution for it. So we're going to be shading. Now, the inequality that we solved for originally, in this case, had a less than sign. So when we solve for it, we set it equal. In this case, again, what we end up having is we end up having the solution of both those values of -3, in this case, and then +2. Now, if I'm looking at this problem as a whole from the original, in this case, that x squared plus x minus 6 is less than 0, what we're going to do is we're going to go ahead and test a point. So therefore, when we do so, and now what you're going to see then is x squared plus x minus 6 was taken from the original problem up at the top here from the 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. So in other words, what we end up doing is we end up taking these two solution bases and figuring out where they actually cross. So in this case, the solution to the original inequality, in this case, what you end up having is you end up having the values between obviously -3 and the x value that is less than 2. So therefore, any one of those values that I plug in for x, in this case again, would end up working for the solution. And we're going to talk about how we can find the solution by shading, in this case, to find it. So therefore, what you end up noticing is if you use the original, then you can plug in any of the values. And what you end up noticing is if you use the originals, in this case, any x value to be normal, the x-axis actually will end up working and giving you a solution. So I'm just going to shade that a little bit. So you can kind of just see it a little bit better. In this case, any value below that and will satisfy it. Now, in this case, obviously, once we solve it and we set it equal, obviously then those values fall between the values of -3 and +2. So that's the idea. Again, we'll talk about more as we kind of get into correcting two different kinds of inequalities, and then we can find our solution base from there. All right, so at the bottom here, it says now instead of graphing, we can now use the idea of solving the equation, x squared plus x minus 6. This will give us the same solutions if we solve it. Does this give you the same solutions? In this case, yes, because if you look at the original, again, we end up with the same values that we plug in for those solutions. So in this case, again, nice easy problem, and kind of to solve and be able to solve for it. That idea of putting it all together and finding those x-intercepts to be able to solve for the solution. All right, so now we're going to kind of transition. I'm going to go down to the back side. So in this case, it says use any method to solve the inequality x squared plus x minus 10 is greater than or equal to 0. So in this case, what we're going to do is we're going to go ahead and solve this, and then we're going to go ahead and plug this value out of a number. So first thing, as you can probably guess, is I'm going to go ahead and do step 1. We talked about a couple of days ago, or excuse me, a couple of weeks ago. In this case, it's going to be x squared minus 3x minus 10. And I'm going to go ahead and get rid of that inequality because I'm not going to worry about it for the time being and set this equal to 0. So in this case, what I want to do is I want to make sure that I can go ahead and factor to find my boundary point. So in this case, I need two numbers that multiply to -10 and add to -3. In this case, it's going to be x minus 5 and then x plus 2. And those are both going to be total value 0. Now I'm equal to, I want to add each. In this case, it's going to be x equals 5 and x equals -2. Now those two solutions then, because become, again, what we call our boundary points. So our boundary points, again, end up becoming the solution for our problem here. So therefore, I'm going to go ahead and plot them. In this case, I'm just going to put like -2 over here, and I'm going to go -1, 0, 1, 2, 3, 4, 5. I'll put that right there. Now, if I look at the original problem, the inequality tells me whether I fill in the dots, or in this case, open them. In this case, I can leave both closed, because we talked about if they're equal to, be filled in, and they're going to be part of a solution. So now what we need to do is we need to, again, test a boundary point from, again, either on the inside or the outside to figure out where we have the shape for this solution. So in this case, what you're going to end up noticing, I'm going to go ahead and plot the value of 0 onto my value. So that's the one kind of right in the middle there. So that 0 is going to kind of determine the solution to this problem. In this case, again, we're just going to call this thing check. When we do the check, and it's nice and easy. That way we can solve for our problem and be able to find our solution pretty easily. So in this case, what I'm going to go ahead and do is I'm going to go ahead and plot that value. In this case, I'm plug in, so therefore, parentheses 0 squared minus 3 times 0 minus 10 is greater than or equal to 0. Now, what you end up seeing here is you get 0 squared is 0, and 3 times 0 is 0, and then you get -10 is greater than or equal to 0. Now, hopefully you can figure that out. It's pretty straightforward that this problem actually, again, doesn't have that specific value, so therefore, in this case, it's not true. So that means 0 isn't actually part of our solution. So sometimes what I do is I write no underneath that middle part to kind of remind myself. In this case, again, since it's a no, what we're going to end up doing is we're going to end up shading on the outsides to the right and to the left. So therefore, we're going to go ahead and shade it in and draw my arrows. Push it down. Okay, so now it asks for our solution for the problem. Well, in this case, our solution is going to be anything that is going to be less than or equal to the value -2, or in this case, anything that is greater than or equal to the value of 5. Okay, so this right here is our solution. Now make sure you put the word or, because in this case, again, when we say or, we're talking about two different solutions here. If we say x has to be less than or equal to the value -2, or in this case, again, you can have that other solution, in this case, the one that is greater than or equal to 5. So again, you kind of get that solution, so you can kind of solve with that. Now, in this case, the next problem, we're going to kind of keep on rolling here. It says, next, Bert and Ernie were at it again, and they were working on something inequality 4, and then the absolute value of x plus 1 minus 2 is greater than 6 from the problem 459. This time, why don't we graph the system equations like we did with 458? So kind of talking about the solution there for each one that we kind of talked about the last problem. It says, what is the system of equations should we include in the graph, and the graph, the system, and explain how you can use it to find the solution. So therefore, what we're going to go ahead and do is we're going to go ahead and kind of test a point to figure out our solution. So therefore, it says, what is the system should we graph? And we graph the system and explain how you can use it to find them. So therefore, what I'm going to go ahead and do is I'm going to go ahead on the right side, and I'm going to go ahead and solve this thing just like I did with the previous problems. So now I don't have the number line, but now I have the actual graph. So therefore, I'm going to go ahead and solve for this. So in this case, I can again find my boundary points for those solutions. In this case, again, what you can actually do, when you go ahead and find those boundary points, again, you're just looking for those points of intersection. So therefore, I'm just going to go ahead and solve and do the same. So I'm going to go ahead and do 4, so value of x plus 1, and then -2, and then I'm going to write equal to the value of 6. So I'm going to go ahead and see if we can solve for this to find the actual points of intersection. So when I do that, I'm going to go ahead and add 2 to both sides. So I'm going to have 4, then the absolute value of x plus 1 is equal to the value of 8. Divide by the value of 4 on both sides. And then I'm going to get the absolute value of x plus 1 equal to the value of 2. Now, we talked about when we have the absolute value, remember we need to split them because we're talking about both the positive value and the negative value of the distance from 0. So therefore, we have that, and x plus 1 is equal to 2. And then x plus 1 is equal to -2. And then when we solve this, in this case, we're going to get the value of x equals -3. And x equals the value of, in this case, should be, excuse me, sorry, my apologies. I was looking at the other one. In this case, that should have been 1. and the value of -3 over here. I was looking at the one on the right instead of the left, going too fast. So you should take your time. Now, as you can guess, these ones right here are the boundary points. Again, these would be like the ones that we have on the number line. Now, what these values are actually now on the coordinate plane, if you recall again when we were solving for those different equations, these are actually the points of intersection. So again, these points of intersection are actually where the two different equations are going to actually meet up. So what we're going to do is we're going to go ahead and graph this idea in terms of simplifying, so therefore we can actually find where the solutions actually can lie on this coordinate plane now. So in this case, what I do is I'm going to go ahead and graph the first one. In this case, that's the absolute value of 4 multiplied by x plus 1 minus 2. So therefore, I'm going to go ahead and graph my vertex. So if you remember your vertex, this is your hk. So therefore, you have your h value and k value. H value is negative or opposite, so therefore it's -1. And then go down to -2. And then usually we talked about that absolute value. It has that same pattern of over 1 up 1. But in this case, again, since we're multiplying by a factor of 4 here up front, what that's going to do is it's going to vertically stretch it. So therefore, it's going to go over 1 and up. So therefore, over 1, then up 1, 2, 3, 4 for that value. And then the same thing to the left. I'm going to go over 1 and then 1, 2, 3, 4 for that value there. All right, then I'm going to keep going. So in this case, I'm going to go over 1 again, and then over another one in this case, but now I'm going to go up 8. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to the value, go to the other side, and -8 over here as well. Now, if I keep going, in this case, I think it actually fit one more time. Here we go. So we can go all the way to the top, and I'm going to go ahead and graph. Now, here's where it gets a little tricky because in this case, sometimes inequalities aren't always going to be the solution. So when you ever see this kind of function, in this case, it has the less than or greater than sign. When you have that, what's going to end up happening is you're going to end up using either a dash or a bold line. Since we have the inequality here written together for the two different equations, in this case, what we're going to end up doing is we're going to end up using that solid line. Usually when you have a greater than or less than sign, usually you end up using the idea of a dashed line. But in this case, we're not talking about two separate equations, we're just talking about one here. So again, we're going to just use the solid line. So there's my solution. Now, the other one is the value of 6. So some of you are like, well, how the heck do we graph that? Well, again, if you make this a little different and add 0x to it, some of you are going to be right away like, oh, this makes sense. In this case, again, this is a slope. So in this case, what we do is we have a slope of 0. And we're just actually putting the value at the y-axis. So in this case, the y-intercept of the value of 6. So in other words, what we have is we have a line that has no slope, but again runs through the value of y equals 6. Now, some of you are going to look and say, hey, what did we just talk about? Well, in this case, the solutions for this problem, well, the solutions right here are exactly where we found the boundary points. So in this case, what we end up seeing that these boundary points are also the points of intersection on a coordinate plane. So who knew? In this case, again, very helpful hint and tool to help you find those specific values to solve for them. So pretty neat if you ask me. So now with that same kind of idea, what we're going to do is again just figure out where the solution could lie. So in this case, again, what you'd end up doing is you just end up plugging in a value to see where the solution actually lies. So again, if we're talking a number line, in this case, again, we can just graph it. The same kind of idea for the solution as well. Excuse me. So in this case, what I'm going to go ahead and do, I can go ahead and try a value. And I can go ahead and just try the value of 0 again, just to make sure that it works. So I'm going to go ahead and do 4, and then if the value of 0 plus 1 minus 2 is greater than the value of 6. And again, this is my check. So therefore, I'm going to plug it in. So plus 1 gives me 1, and then 4 in the absolute value of 1 minus 2 greater than 6. 4 times 1 gives me 4, minus 2 gives me the value of 2. So 2 is greater than 6. As you can probably guess, that is not the true point. So therefore, what we end up noticing is, again, we end up having a solution that, again, is going to be split. So in other words, what we end up having is we have any x values that's going to be less than -3, is going to work here, or x value that is greater than 1, in this case, will also work as a solution. And you ask yourself, well, how the heck did you get that? Well, in this case, again, if you just put a little number line down and think about it in terms of the values, again, -3 and 1, 0 is in between them, kind of like we had up here. In this case, again, when we tested it and we ended up noticing there was a no, in this case, again, it ended up changing to the outside. So in this case, the inequalities kind of flip and they change their sign. So therefore, we end up with a solution. Now, some of you are asking, well, how can we figure out in terms of graph? Well, the only way we can figure that out is if there's two different inequalities for each. So in this case, again, if it's asking for the values that are greater than the value of 3 or 6, we would take it actually above or below, depending on again whether the inequality is favoring the value for y, and vice versa for those. So in this case, again, what I end up doing is end up again setting these both equal to y, and then getting the inequality. So in this case, again, we have them one together, therefore we can't really shade our solution. But in this case, as you can see, we end up getting the values there. So that's the problem for 461. Overall, not bad. I thought that was kind of helpful as well. All right. So the last part of our lesson here today is we're going to go ahead and take a look at problem 463. So in this case, 463 says that for each of the following graphs, find the equation, inequality, or system that you could have for the solution shown. So note the equations for the line and the parabolas that are given. So in this case, again, each one of these is given to you for the problem itself. What you're trying to do again is you're trying to write, in this case, the equation or the inequality to make these values true. So in other words, what I'm going to do is I'm going to go ahead and take a look at the problems for each one. So for letter A, what we end up having is we end up having two different lines. I should say line and parabola. In this case, the parabola, obviously, as you can probably guess, is going to be the value for that y equals -1/3 multiplied by x of 3, and the next one is 4. The reason why is because in this case, you multiply those two x's together right away, you're going to get the value of x squared. The other one, in this case, is a line, and it's going to have a negative slope. And as you can see, it's written in standard form, x plus 2y is equal to 4, with that solution there. So what we're going to do is we're going to go ahead and see if we can actually solve for the equation and figure out the actual solution for them. In this case, for letter A, what you're going to notice is right away that they're not actually solved for anything. So what we actually need to do is we actually need to put that standard form equation, x plus 2y equal to 4, into the intercept form, because in this case, I'm going to solve for the value of y. I'm going to figure out the x value. So I'm going to go ahead and minus x on both sides. And then 2y is equal to the value of -x plus 4. And then I'm going to divide by 2 on both sides each. And I end up getting the solution for my equation. Y is equal to -1/2x plus the value of 2. So in this case, now this thing is set equal to y. And therefore, my solution, what I can do is actually, if I want to write the equation, find the intersection. If you remember, you're just going to take that idea of -1/3, x plus 3, and x minus 4, and set it equal to the value of -1/2x plus 2. So right here, this is my actual solution to the reason why is because, again, we're just looking for the points of intersection. So therefore, again, we don't have anything shaded, and we don't really care either, because in this case, what we end up having is we end up having that solution that will allow us to, again, solve for it. So nice and easy. I think that was a pretty straightforward problem. Most of us have been doing this for a while now. With that letter B, in this case now, what we end up having here is we end up having a solution. So in other words, the solution, again, in gray is what makes the answer to both these inequalities. Excuse me. So what I'm looking at here is I'm looking at, again, two different lines. The first one, again, obviously, as you can see, is in standard form. I'm going to go ahead and write it in my intercept form, because in this case, I'm going to end up finishing writing it as an inequality eventually. So what we're looking for is we're looking at the solution base, and we're saying, okay, now consider which ones of these are actually going to work. So if I look, how I write these inequalities is the same kind of idea that looking at, again, on greater number sign. So in this case, anything greater is usually considered value up or above or just more of it, right? So if I look here, if I take this line right here and kind of flatten it out, if I look and I take this and I kind of make it horizontal, What I end up noticing is that that solution is shaded above that line. So anything above, again, we usually say is the value that is greater than. So in this case, when I end up going, or what I'm going to do is I'm going to go ahead and take that equal sign. I'm going to get rid of it. I'm going to go ahead and replace it with the value of greater than. The reason why is because in this case, the solution is going to be anything greater than that equation right here for x. So therefore, negative 1 half x plus 2. So what the nice thing is, in this case, the solution, if I plug in any value for this, and I get out that value, for example, if I plug in the value, look here, in this case, I start at 0 and I go 1, 2, 3, or excuse me, sorry, that was wrong. Over, excuse me, and then do 1, 2, 3. What you end up noticing is you end up noticing threes in the solution. So what I can do is if I don't actually think it works, I can plug in that coordinate because in this case 303 says it should work. So therefore, if I look at it and say, all right, it's 3, and then I'm going to plug it in as negative 1 half times 0 plus 2, what you end up noticing is 3 is greater than 2. That actually works as a solution. So in this case, here's one of your inequalities. So again, just a little hat up the tip there to kind of figure out how we can get specific values. All right, and then for letter B, in this case, as you can probably guess, in this case, since it's underneath this line, and again, if I took this and kind of pulled it apart, in this case, the solution is shaded underneath, so therefore that's going to be the less than sign. So we got to have y greater than negative 1 half x plus 2, and what we need to have is we need to have y be less than the value of, in this case, negative 1/3, and x plus 3, x minus 4. Now, here's another thing to consider. In this case, you may have noticed this. One of them is actually a dashed line, and the other is, in this case, I think also a dashed line as well. So what we're doing here is we're actually going to figure, in this case, when we have solid versus dashed lines, solid lines actually are going to be used as the idea of equal. So we use a solid line just like using the fill-in dot on the number line. When we have both of those, the answer on the line is actually going to be part of the solution. So in this case, again, any value that I plug in with that for x and y, again, will work as a solution. So therefore, we're good to go. We got our solution base. All right, so now we're going to go ahead and figure out for letter C, which one is that. So as you can see from the problem, right away, I'm looking and saying, okay, well, we have that solid line, and we're going to be obviously less than the value of 1/3 x plus 3, x minus 4. So I'm going to go ahead and just write that right away. So y is, again, less than or equal to the value of negative 1/3 multiplied by x plus 3, and then multiplied by x minus 4. Now what you end up noticing here is, again, similarly to the last problem, in this case, again, we're looking at the expression for the x plus 2y is equal to 4. Now, when you look here, though, what you end up noticing is you end up noticing some of it is above and some of it is below. Well, in this case, that isn't possible because you can't have an inequality that works like that. The inequality, again, either has to be above the line or below the line. So if it is in both, what you end up having is you end up having a solution. So in this case, x plus 2y equal to 4, that actually doesn't actually equal anything because in this case, again, you can't have that inequality actually serve as the solution base here because in this case, again, we're shading both above and below that dashed line here. So in this case, this would end up being an inequality. In this case, anything less than or equal to the value of that parabola. And then in this case, again, since we don't have a solution there, we can just go slash through it and solve it out. So in this case, nice easy problem. Pretty straightforward. I think it's kind of always fun to do those as well. All right, and the last one. So in this case, if I look for letter D, again, I'm given those two different equations. I'm going to start with the value of y is equal to, in this case, negative 1 half x plus 2. Now, as you can see, what we have is we're above the line again. So I'm going to go ahead and say above. And therefore, I'm going to go ahead and have the value that is greater than. So go ahead and y equals greater than negative 1 half x plus 2. And the same thing now for the parabola. In this case, again, since we have a solid line, we're going to go ahead and write y is equal to less than negative one third, then x plus 3, and then x minus 4. So that's another part of the solution. Now, what you may notice is you're like, hey, what about this part here? Originally, again, we had the same inequality written over there. In this case, even that little itty bitty part, that little pizza slice there, was included as a solution as well. Well, in this case, this is another special case scenario because we actually end up having another inequality. Because if I look, in this case, anything that is greater than that zero for the solution, in this case, works within that inequality. The other one, in this case, is less than zero. As you can see, the solution is nowhere near any value that's less than zero. So negative one, negative two, negative three, and so forth. In this case, what we're going to go ahead and do is we're going to go ahead and write the last solution. So in this case, x has got to be greater than or equal to the value of zero. And the reason why is because it's actually on this y-axis here. So in this case, that y-axis is a solid line, and our solution base falls right in that as well. So as you can see, we end up having inequalities, and they can tell us a lot about these problems. So again, this is problem section 421, day 2. How can I solve inequalities? Hopefully you're feeling a little bit more confident with these. Again, we're going to get plenty of practice with this. So if you're struggling with it, you're like, this is not making sense. Again, they're going to be showing up on a review, quiz on this next week as well. So again, we'll have plenty of practice within our toolkit and such, and we kind of go from there. But I appreciate you guys being so flexible, especially with obviously coming in with only 2 days and then kind of going right into semester exams. Hopefully you found this video helpful. Please make sure that if you have any questions, you're emailing me or just letting me know in general. I will check homework when I get back. So again, if you got those homework assignments, I will check them when I come back on Monday. Otherwise, have a great rest of your week. Hopefully, you enjoyed your holiday break and feeling rested to kind of finish the stretch run. So, have a great rest of your day. We will see you all when I get back on Monday. Have a great rest of your day.